And welcome to live stream number 43. Today is Thursday. It is August 10th and it's 2017. If you're watching this, you are watching the recording because I haven't quite gotten anybody inside of the live stream yet. Down in the description area of this video, you will find my email address, lars.christensen@autodesk.com. If you have any future topics you would like to get covered on this live stream, send me an email. I would love to hear that. So, now we're just gonna get a couple of people in here. Today's topic is beginner sheet metal. Understand KFactor. So, some of the people who's gonna jump in here maybe were on Monday's live stream when I was saying, and you can see we already got Sammer in here. And I said on Monday that I was not going to do a live stream again until next Tuesday, so 5 days from now. But then, what happened? Well, Fusion 360 came out with sheet metal. I knew that, but that was absolutely awesome. And I've gotten some questions about sheet metal. Now, today is not going to be a fully deep dive into the sheet metal functions. I will come back to that later. I want to talk about KFactor today. Because if you don't know what KFactor is when it comes to sheet metal, that can really play with you a little bit. So if you are an old-timer who have done sheet metal for years, know KFactors, understand all that, then anything you have to add, put it down in the description area or in the live stream. Share the knowledge, right? I would appreciate that. But for people who are not familiar with KFactor, well, if somebody's trying to use sheet metal for a project and they ending up with a result that they didn't expect, well, when that happens to me, you get confused. You're trying to play around with it, trying to figure out why things are the way they are. Then you get frustrated, then you get mad. I might start crying, but then I start drinking scotch, and then everything's fine again, whatever. So I wanted to explain KFactor because I think that that's extremely important, and I actually think that it's something that the CAD companies in general have never really, I'm not familiar with anybody really sat down and said, KFactor, this is what it is. So I can see we got 42 people in here. It's absolutely awesome. Really appreciate it. Yeah, so let's jump in and talk about sheet metal. Let's talk about the KFactor. Let's get that all straightened out so you at least understand, if you're new to sheet metal, what that is all about. So over to Fusion. And I actually, you know what? I'm gonna do this just because somebody told me that I should do things in metric. We're going to do this in metric. So I'm in the modeling environment here. And what I'm going to do is I'm just going to sketch up on this plane here. This is not really important. I'm going to create a line. I'm going to sketch it out horizontally here. I'm going to make it 75 millimeters long. If you are in standard, this is about 3 inches. Doesn't really matter. Now I can see this line is going up and down. I'm going to make sure that it at least is horizontal here. Then I'm going to draw another line, and I could do relationships, but just for this case here, for the fun of it, I'm going to make this one 75 also, and then I'm going to place instead of just doing a constraint or relationship here, I'm actually going to put in the 90 degrees. So what we have here is we have two lines that are each 75 millimeters, or about 3 inches, and they have 90 degree bend on them here. All right, let's get out of the sketch. And the reason I did it this way is because I actually want to show this. So if I go into the sketch and right click, I can say show dimension. So that just makes it a little bit, easier to look at here. So let's go into sheet metal. And I have not really played as much with sheet metal as as I want to. But this flange tool that they came up with is really amazing, it seems like. Like whoever on the development team came up with this tool really looked like that they did a heck of a job. So I'm gonna go ahead here and I'm gonna make this one also the flange we're creating here. I'm gonna make it just for the way I'm looking at it, -75. And like I said, I'm gonna do videos later on where we're gonna get a lot deeper into this. But for right now, notice my sketch line is going on the inside here. For this example, I'm gonna switch it to the other side. So our 75 by 75 is laying kind of like at the bottom of this bend here. You got different options in here, not really important for what we are doing right now. So now we have this kind of flange here, and this is gauged by a rule that is propagated over here, and you can modify sheet metal rules in here. Just gonna go normal to here, because you might just right now saying, well, wait a minute, suddenly I got a thickness in here. Where did the thickness come from? I never defined a thickness, I just defined the length. And that is coming out of these sheet metal rules in here. Now, if you scroll down in the description area of this video, you'll find a bunch of links in there. Just click on them. But there's one of them that is called to add or edit a sheet metal rule. So this is called a sheet metal rule. This is out of the Autodesk knowledge base. So just remember that one is down there when you want to dig deeper into this, because like I said, I'm not going to spend too much time talking about that. We're going to talk about the KFactor. But if we go in, so we can see right now that this is steel, this is millimeter, that's the default. And if I go into the rule in here, you will see that in this design, that is the rule we're using right now. Now, there is a library of other things in here, and what we're going to end up doing is we're going to end up creating our own library in here. Because if I expand the steel, the one we're using right now, you will see that there's a thickness of 2.5 millimeters, and that is actually what the thickness is. Then you have this KFactor, and that's what all this video is about. So KFactor is it's a distance that really there's not really any good math formulas to come out of this. So let's talk a little bit about KFactor now, where we are here. So we have our sketch. And this sketch here, like we would take a flat piece of metal, right, a plate of metal, and we would then bend it up in 90 degrees. Well, when you bend metal, then what happens in the corner here, and you know this, is that this edge here will actually be a little stretched, right? And this edge here would actually be a little compressed. When you are doing something like that, what actually means that if you are going to, if this here is 75, this is 75, so you know your logic is saying, well, that's two sides of 75, that's 150 millimeters. But actually what happens is that when you bend that 90 degrees up, you're actually stretching the material a little bit. What means that you actually need a smaller piece of material, less than 150, to get 75 by 75. Now, some of you guys might thinking that, well, you know, does that really matter? Well, it does if this is just a 90-degree bend. If you, for example, are doing like a full enclosure, that really matters that you stamp it out at the right length. And it's that KFactor we're using to figure out how long we're gonna make, how big the plate is we're gonna cut out to be able to make to fold it up 90 degrees and have 75 by 75, because that's the end result. The flat we're cutting out, we need the right number, so when we fold it up, it's 75 by 75. Does that make sense? I hope that makes sense in here. So the KFactor is, if I go in here And let me open up another sketch. So I'm just going to create another sketch on this face here. And I'm just going to project the edges here. Right here to here. And if I do an offset of that projected edge, right here, and this stock was 2.5, so we're going to do 2.5 divided by 2. That should, in theory, give us a line that runs right through the center, kind of like the center line of our flat stock here. So what the K factor is that when we fold this thing up, like I said, it stretches here, it folds in the inner center here. This this line actually gets moved over a little bit, and that number that it gets moved over is the K factor. What is the one that we put inside of that rule? Let's go back into our rule. That is this number in here. So somebody who's going to design something for a sheet metal fabrication shop, or if you were doing, you can actually also use sheet metal for other things like cardboard or other things, might say, all right, so what should I have the K factor on? It depends. And the reason it depends, it depends on the material, but that's okay because we know that inside of Fusion. But then it actually also depends on the specific tool that is used on the shop floor. So every tool, depending on what radius they're bending with, the bending tool can actually vary. So each shop will have a little bit of a different K factor depending on how accurate this bend is. Now, a general rule that I've always lived about, and again, like some of you guys who are, sheet metal ninjas, be welcome to put down in the comment area or in the live stream. But the general rule is softer material, you normally would go with a lower value. Harder materials, you will go with a higher value. And it normally plays in. So like something like copper, for example, is very soft, would have like a K factor of 0.3, where something like hard steel will have like a K factor of 0.5. So that's kind of like a thumb rule in there. I also left a link to down in the description here to something called Sheet Metal Guy. And he actually has some different calculators for different things and have written up a lot about this. So if you want to dig deeper than what I'm giving you here, then you are more than welcome to do that. But so it's this K factor that happens when we are bending, and that is the one that controls the flatten. So let's go back into Fusion here. And right now, like I say, we're using steel, and you will see the K factor right now is set to 0.44 in here. If I go in right now, and I go in, and so right now we can agree on we have 75 by 75, so 150. But if I go in right now and I say I want to create a flat pattern, and I'm just going to select the bottom face here, and then it's going to flatten the piece out. If I go up and select this edge, by the way, if you didn't know this, you need to know about that. If I select this edge, it will actually give you the distance down here. And of course, because my default is inches, it shows up in inches for the flat pattern too. Let's change that to millimeters. All right, let's try that again. Select an edge. So the 150 with a gauge factor of 0.44, we would actually only have to cut the length out of this of 144.65 to be able to get two sides again, because we're stretching it. So what I could do here, so this is one, so if you remember this, write it down, 145.65 something. If you go back and exit out of the flat pattern, if I changed one of these rules, so this is what you kind of have to do. You have to kind of like fit this to what is in your shop, because like I said before, some shops, if you're already doing sheet metals, a lot of shops already have this completely down and they're all set with this. But if you have to deal with somebody outside, you might want to reach out to them. What you can do is we can, for example, go in here and let's say that we change this to an aluminum here. If I right click, I can actually create a new rule. So I'm creating a new rule. Let's say we're going to do this for aluminum, and I would probably, here you will change it to some kind of a whatever gauge material you have. So I'm creating a new rule, and I'm going to leave it at the same thickness, 2.5. But then if I change this K factor to 0.5, well, it's a soft aluminum is softer, so it'll actually be less. So I don't know exactly what you're going to use. Now be aware of there's a lot of different options in here. This is for another live stream with the you can control the reliefs and things like that. But so we're changing out, making our own aluminum. We're going to make it at a K factor of 0.3 instead of the steel right now is 0.4. So if I go up to the rule up here and I change the rule, so I'm going to switch rule, go back into the library, and now you will see that we have Lars aluminum. So I'm going to switch it to that, and as soon as I do that, the flat pattern knows that something is not right. So I can right click on that and say update flat pattern. That will update that. And then if I make it active like this and we go and select it, you will now see that we had we're ending up with a different length in the soft aluminum because we changed the K factor. So by changing the K factor, then we get a different length. So that's what KFactor does. KFactor will control when we make a flat pattern. It will control where how long we have to cut this piece of plate out to be able to fold it to get the right enclosure. So what you need to do, well, it depends on what your situation is, of course, if you're going to use sheet metal. But like I said earlier, I really wanted to create this video quick because if you have never used sheet metal before, this is the first time you're kind of like dabbing into it on your own and you don't know what K-factor is, it's gonna frustrate you, right? When you do the flat pattern, you're gonna realize that why is things not the same size? That's that K-factor in there. What you can do, like I said, you kind of have to do some testing if somebody in your shop floor can't give you K-factors. Like I said, some of them already have it. So one way to test this is to go in and take a part like this, if we change the angle here from 90 to 70, like this. So if you go out on the shop floor and you say, all right, let's bend this piece of metal into 70 degrees, and then if you measure, so I'm going to hit D, I'm going to open a new sketch here. Let's open a new sketch. Edit. Oh, we're already active here. Let's create a new sketch here. So if I go in and if you bend this piece of steel and then hit D, and then if I make a measurement from this face to this sharp corner down here, okay, and it's going to come up with this warning, adding this dimension will over-constrain the sketch. So it's going to end up being a driven dimension, which is okay. It's not just not doing anything, but it's still there. It gives you what this should measure right here. And then I can do the same thing if I do a measurement from here up to this sharp edge, right there. I get another number. It's going to also be driven. It doesn't really matter. So now I have these two numbers, and then I can do this in CAD. Now, if my K factor is off, remember we did a K factor of 0.3 for this piece of aluminum, then you will go out and measure, and you measure this to be 70 point, let's say 71. That's the measurement you get. Then you will go in and you will tweak. You will tweak the flat pattern. You will tweak the rule. So you'll go back into aluminum in here and say, all right, so it measured 71. So let me go in and edit this rule, and maybe you try to make it, 0.35, you save that, you hit OK, you update the flat pattern, and then you will bend a new piece of material. You will go in and you will go in and again take your dimensions in here and show and see if you can get closer. These dimensions here, you will bend it again at 0.35, and then you will measure again till you get the right number. So I hope that makes sense. So you will flatten this out. So now we change the 3.5, what means that now this number is different than when we had it at this number is different now than at 3, right? So then you will take this number here, you will cut that little piece of material out, you will bend that up on your machine, you will recheck that these numbers, and you're getting closer to these numbers, and that's a way to find the K factor. I hope that made sense. Yeah, so K factor is important to know. If you don't know about it, so you would actually go into that library inside of the rules and create your own rules. I hope this was not too confusing. If it was, let me know down in the comments area below. Thumbs up if it's good. If you don't like it, thumbs down. Like I said, I wasn't planning on doing this live stream. 43 was supposed to happen this upcoming Tuesday, but I thought that this was really important to cover for any of you guys who this whole new experience this whole new sheet metal is a new experience. I hope you found this helpful. I'm going to do as I normally do here. I am going to end the broadcast. If you have any future topics, grab my email address down in the description area and send me an email, and I will jump in the live stream and just say hi to everybody. So until the next time, have an awesome day.